As we know that consolidation is nothing but the change in the volume. This particular change in volume we generally take into account with change in depth only. As we know that the soil is semi-infinite material, it is having an infinite area, right? So whatever is the change in volume, we take into account that in the case of or in the terms of depth only, right? So if I am saying that there is a change in depth, that is the consolidation, I can say that it is also a settlement value, right? So we are more focused about the consolidation settlement, right? Now there are mainly the three formulas by which you can find out the consolidation. All the formulas are correlated. If this particular formula is known to you, you can derive all other formulas also, right? So what is your first formula? Your first formula is delta H. Delta H is your total settlement. Remember, this is your ultimate settlement value. So your ultimate settlement upon thickness of compressible layer, it is given as delta E, change in void ratio upon 1 plus E naught. Clear? Second formula is your settlement value. It is nothing but thickness of compressible layer into MV. MV is your coefficient of volume compressibility into change in effective stress. Now this is the particular term which is important for you. All other terms you might be knowing. This is your coefficient of volume compressibility. The formula for this is MV is equal to there nothing but it is your AV upon 1 plus E naught, right? And what is this AV? This AV, it is your coefficient of compressibility, which is nothing but the slope of your void ratio versus effective stress graph. Void ratio versus effective stress graph. Clear? So this is nothing but change in void ratio with change in effective stress. When the stress value will increase, obviously there will be decrease in the void ratio, that is given by that particular graph slope. It is given by this particular term, that is your coefficient of compressibility. Clear? So these are the some coefficients which are used in this particular chapter. Now this sigma bar, delta sigma bar, this is the particular important term for you, right? Now try to understand. Let's suppose this is your particularly foundation, right? And there will be a load from the superstructure. Now due to this particular load, you need to find out that what will be the settlement of this clay layer. Above here it is sand, below also it is sand. Above here it is sand, below also it is sand, right? So we need to find out what will be the consolidation settlement in this particular clay layer. This is your clay. This is your clay, right? So the stress value which we calculate, these are calculated at the center of this compressible layer. As we know that the stress value, it is also the factor of depth. It is also the factor of depth. So sir, where I have to take the stress? At this particular point or at this particular point, right? At this particular point is also clay, at this particular point is also clay. So if I am moving downward, definitely there will be change in stress. From our effective stress chapter also we have seen that the stress at any particular depth, it is given by gamma, that is unit weight of that particular material divided by depth of that material. So what we consider, we take the stress value at the center of this compressible layer, right? So where we calculate these stresses? At the center of the compressible layer. Clear? So whatever is this delta sigma bar, this delta sigma bar is the change in stress value. This sigma bar is change in stress value. It means there will be initially some stress, after that there is some change. Now try to understand it. Let's suppose there is no foundation. Let's suppose there is no foundation, there is no superstructure over this particular building, right? Even there is no particular building, there will be some stress at this particular level. There will be some stress at this particular level. The calculation of this stress we have studied in effective stress chapter. The calculation of this stress we have studied in effective stress chapter, right? It means the stress value at this particular point, it will be due to this overburden pressure, right? Or due to the weight of this particular soil. That is your initial pressure, that is sigma naught bar. I am calling it as initial pressure, right? That is your initial pressure. Clear? Now, after that, you have constructed this particular superstructure. Due to the load of the superstructure, also there will be some stresses at this particular level. Again, there will be some stresses at this particular level at the center of compressible layer, right? That is your delta sigma bar. So your effective stress changes from this value to this value. This is your change in effective stress, change in stress value. Clear? So this is due to your superstructure load, due to superstructure load, right? And this is due to your overburden pressure. Overburden pressure. Clear? Now, how to calculate these stresses? Sigma naught bar, we know that we only have to take whatever is the gamma value of the material, multiply by this particular height. That will give me the sigma naught bar value. This stress value due to the superstructure, this stress value due to the superstructure, we know that whatever is the load at the base of foundation in soil, it is going to get distributed. In this particular soil, it is going to get distributed. Now, generally examiner will give you that at what particular angle this particular stress value or load value is going to get distributed. If it is not given, you can remember the standard value. It is 2 vertical to 1 horizontal. 2 vertical to 1 horizontal, right? So let's suppose your load value from the top is Q. Your load value from the top is Q. The width of foundation is B. The width of foundation is B, right? But you need to find out what will be the stress value at the center of compressible layer. You need to find out what will be the stress value at center of compressible layer. So to get that stress value, you have to divide this load with the area at the center of compressible layer. At the center of compressible layer, right? So let's suppose this width is B. It means I need to find out this particular dimension. I need to find out this particular dimension, right? So let's suppose this particular depth, it is Z. It is Z. It means I am moving Z down. If I am moving Z down, it means this will be what your, it will be your 0.5 times of Z. Yes or no? Or just for now, I'll write it as n times of Z, as this particular n value can be anything. I am assuming that it is n horizontal to 1 vertical. Clear? The load distribution is 1 vertical to n horizontal, or you can say n horizontal to 1 vertical, right? So it will be your n into Z. This particular value will also be n into Z. So you can find out what will be the dimension at the center of the compressible layer. If you will divide that particular load with this particular area, you are going to get this delta sigma bar. Clear? And if you will add these two values, you will get the final stress value, that is your sigma 1 bar, that is nothing but sigma naught bar plus delta sigma bar. So these are the parameters which will be needed for you to calculate the settlement value. Clear? Another formula for the calculation of settlement is your delta H. Third formula. These are the two formulas. Third formula is, or I'll write all the formulas again. It is delta H upon H is equal to delta E upon 1 plus E naught. This is your first formula. Second formula is delta H is equal to H into mv into delta sigma bar. And your third formula is delta S is equal to H into Cc upon 1 plus E naught into log base 10 sigma naught bar plus delta sigma bar upon sigma naught bar, right? Now this is new coefficient Cc. This Cc is your coefficient of compression. This is your coefficient of compression, right? This is nothing but your slope of E versus log sigma bar curve, right? So it is delta E upon log sigma 1 bar upon sigma naught bar. Clear? So this is the particular CC value. So these are the three formulas by using which you can find out what will be the settlement at any particular clay layer.